Hello and welcome everybody. Thanks for joining us today. I'm Tessa and I'm going to be facilitating today's webinar. So on the webinar today, we have our Senior Sales Engineer, Kevin Scott, and the topic is deploying ETL to the cloud. So Kevin will be taking a look at the architectural patterns and anti-patterns of cloud when it comes to setting up data posters, as well as the technical considerations and some caveats you might encounter. So just a couple of housekeeping notes before we start. We'll be answering all the questions at the end, so if you do have any, please just use the Q&A box to submit them. Also, we're going to be sharing the slides and the recording after the webinar, so you should all receive these tomorrow by email. So keep an eye out on your inbox for that. So with that, I'm going to hand over to Kevin.
Great. Thanks, Tessa, and thanks everyone for joining. We're happy to have the opportunity to share a little about what we are seeing as our clients consider moving their ETL processes to the cloud. The why, I think, is probably pretty obvious to all of us by now. Much of our data and many of our business applications have already made the move. ETL, in a sense, is a trailer of sorts following our data as it moves to the cloud. As a business, the main advantage of delegating ETL infrastructure to a cloud provider is that they are almost certainly going to do a better job of it than we can, right? Cloud providers have deep investments in things like security and availability and reliability of infrastructure. I mean, that's their primary business. We, on the other hand, as ETL owners, are rightly primarily focused on our business needs, right? Getting our data correctly delivered to wherever it needs to be. It's really unlikely we can match a cloud vendor's ability to provision secure and available infrastructure. And this actually, in turn, can lead to sort of the idea of a reflected trustworthiness, right? Our business partners, our customers, our end users are likely to have more confidence in our solutions if they know that they're deployed on, top tier, highly regarded infrastructure. Now, not all of our ETL workloads are meant for the cloud. Some ETL belongs on-prem, particularly closed systems where all the data originates and is staying on-prem. But there are many situations where the best location for ETL, either cloud or on-prem, location is not immediately obvious. Hybrid environments, for example, where data is distributed across local and cloud systems. We have a real interesting choice about whether to run the ETL on-prem or in the cloud. We can do it on-prem, right? We can deploy the ETL process on-premise and push data to the cloud. We may have legacy ETL systems already in place, so it might make sense to keep them right where they are. Alternatively, we can move ETL to the cloud, right, and pull from necessary on-prem data sources. Well, our topic today, and the way we got you here, was to talk about ETL in the cloud. Assume that decision's for now. We'll set the idea of on-prem ETL solutions aside, right? But that actually, in turn, opens up a series of additional interesting questions. Specifically, what type of cloud deployment? Once we decide to go to the cloud, what type of cloud deployment model make? Right? You can categorize these in a couple of ways, right? There's fully managed model, which treats ETL as a service, right? These are quick to get started and can be simple to operate. The trade-off, though, is that it can be limited if you find missing capability. Say, for example, one of your endpoints that you consume releases a new API. You may not be able to exploit that until your provider catches up. Right? So we find fully managed services can be best for relatively simple integrations between common cloud-based endpoints. The other side is self-managed. Self-managed ETL deployment gives you more control over your ETL, also more responsibility. There are often architecture choices you have to make. You can run your ETL in a dedicated virtual machine, or as one or more images that you can spin up as needed, or even in a completely serverless. With self-managed, you'll have the ability to customize your ETL behavior. You'll typically have more licensing options, actual or subscription, usually available in both those cases. On the cautionary side, though, costs in self-managed deployments can be hard to hit, both in terms of how much it will cost to operate the solution, as well as the labor and costs involved in actually building it out, right? And we'll see later there's some real challenges related to estimating and controlling these costs associated with managing operating, I guess, a self-managed ETL cloud deployment. The choice, fully managed or self-managed, is going to be driven, or at least tightly coupled, to your ETL vendor selection. Some vendors may only offer one model or the other. Again, we're further going to sort of narrow our scope today in this call, and we'll focus on self-managed. That's where our experience is as a company, and so probably where we have more potentially useful advice for you. Right, we'll do that by taking a look at 3 real-world self-managed cloud ETL use cases, right? Something interesting to offer related to the choices made with respect to architecture and security, and some interesting stories about controlling and managing costs of operating ETL in the cloud. So use case 1 comes to us from a consumer life insurance company. They have a reporting warehouse where they track the life cycle of insurance policies, from a client's initial interest to them filling out the application, to getting the underwriting done, to the actual activation, the entire life cycle of a life insurance policy is tracked, and the data about it's tracked in a warehouse, right? The insurance company has field offices. They submit application packages via SFTP, and some ETL process runs through a sequence of steps to transform, validate, and ultimately load data about those policies into some reporting warehouse. They do this in batch mode, typically overnight, so they have a fairly well-defined window in which they have to get all of the incoming policies, opened, parsed, ingested into the warehouse so that they're ready for reporting the next day. Right? This is deployed self-managed in the cloud. In this case, it's Azure. It's actually a hybrid solution, more specific in that it uses 2 ETL tools, Azure's Data Factory and CloverDX. So there are 2 types of ETL here, but also 2 types of deployment models as well, because Azure Data Factory is fully managed and CloverDX is self-managed. This case is also interesting, as we think, because it uses a wide variety of storage services and pays some particular attention to some security services. So let's take a look at the architecture, a diagram of what that actually looks like as it's deployed to the cloud. See on the left, new data from the field offices, so new insurance application packets, are pulled in through the firewall from the FTP, where they are processed by those 2 ETL engines. On the right, you'll see there's 4 separate data storage components. Unstructured data lands in Azure Blob Storage. This is the data that's not ultimately bound from the warehouse. The rest, structured and semi-structured, lands in an Azure Data Lake. And from there begins a transformation, validation, and mapping journey with an intermediate stop at a staging database before ultimately arriving in the production warehouse. Right? So the first thing that might strike you here is, why are there so many components in this diagram? Right? Simpler design for what is pretty basic ETL. You might think of traditionally just as an ETL engine, some disk space, and the databases. Right? And this introduces probably the most significant architecture concept that you need to embrace as you design cloud ETL, and that's the shift away from monolithic applications we typically build on premise, and instead take advantage of collections of services available from your cloud provider. To do that, of course, requires a commitment to becoming familiar with what exactly those services your cloud provider has, and to understand, the subtle nuances and characteristics of each, right? Storage services, for example, can have all sorts of variability. Your ETL provider can provide storage services that have different characteristics in terms of availability, security, search efficiency, read and write speeds, and then of course cost, right? So there's lots of characteristics that you need to think and become fully expert in order to make the right selection, right? Choosing the right combination of cloud services is going to be key to effective cloud ETL design. Here, as I said, we chose blob storage for long-term storage of multimedia artifacts, right? Images that are not necessarily going to be in the warehouse. We need to keep them, but we don't need to necessarily access them that often. Data lake storage for the text data that we're going to immediately use and immediately transform. Now, if we choose wrong initially or other change strategies, the switching costs are relatively small in the cloud. So it's much easier to switch a storage technology or a database technology in the cloud than it would be on-prem. Note, as I said, we're using 2 ETLs here. The Azure Data Factory is fully managed, provided by the cloud, and that can be used to orchestrate some native ETL functions. CloverDX, the other half, is the self-managed ETL tool, provided by a vendor outside of the cloud ecosystem. In this case, the initial implementation of this project was done with native tools with Azure, and then CloverDX was added later because its visual data validation and mapping made the solution much easier to design and maintain. The nice thing, and important to note here, is that these 2 ETL services can easily coexist and even collaborate. Finally, if you note in the lower right, there's a special emphasis on security. This is insurance data, so there's lots of personally identifiable PII data involved in the process. So security is important. There's a firewall, of course, encrypted storage provided by the cloud infrastructure. We're also taking advantage of a service for credential management. That's Azure Key Vault in the lower right, a security storage service where we can keep secrets like the passwords for the FTP and for the databases, right? All of this security, right, can be much more difficult to develop on-prem and honestly even overlooked when you do these kinds of things on-prem. Okay, second use case. This one comes from the healthcare space, right? We have a client where they have large volumes of relatively small, what they call HL7 formatted files. It's a data format specifically related to the healthcare industry. Many small HL7 formatted files are collected from point of service locations like clinics or doctor's offices, right? These messages need to be transformed into some standard format and then pushed, into other downstream systems, right? Message volume is pretty high, 10,000 per minute, and we need to guarantee that each message is delivered exactly one time. Right? So we did this particular solution in Amazon's cloud. I think the interesting parts of this the solution here is that the ETL engine is deployed as a Docker image inside of a container manager. So there's some scale, elastic scale available there. And we're using another service from the provider, event queues, which we can use to help guarantee that message delivery requirement. Architecture looks like this. We use object, Amazon's S3, as a landing zone for incoming messages. This is generally another thing to note and best practice for cloud ETL, and that's to drop incoming data into some landing zone, as opposed to processing data immediately as it arrives in some sort of single operation, right? S3 storage on Amazon is ideal for these kinds of landing zones. S3 is very easy to configure, easy for external tools to push data into. Data can arrive randomly, with peaks, and there's really no concern about file locking or naming conflicts. The storage service takes care of all that for us. So there's an ETL process that monitors this S3 storage and collects some of these incoming message files into micro batches, and then puts those micro batches on an Amazon queue. Then a separate ETL process pulls events from that queue, transforms each of those HL7 messages into a standard JSON format, and pushes them into a downstream API for further business. Right. This architecture, it's using containers for the ETL engine and event queuing. Those things combined provide really robust support for scaling, right? The messages that are incoming can be processed independently, so ordering is not necessary. So we don't have to worry about the order in which we process the messages, and that allows us to think about spinning up additional ETL processors as message volume dictates, right? So if there's a sudden increase or spike in incoming messages, straightforward using this containerized application to spin up another instance of the ETL engine and sort of scale vertically in response to just pure load, all right? But what's also interesting here is that we can scale horizontally here as well, and introduce the concept of priority queuing. Say, for example, one of the point of service clinics, right, or hospital, or one of the providers of these messages needs to have those messages handled at a higher priority, right? So we can treat those, we can take those messages and put them on a separate AWS message queue, a priority queue, and then spin up yet another ETL engine from the container manager and have it as the dedicated ETL processor to handle that queue, right? So we can scale here in this ETL-based, in this cloud-based ETL architecture, we can scale both horizontally and vertically, right? Much easier to achieve this kind of elasticity in the cloud than it is on premise, right? If we were designing this on premise, we would probably size our servers for some traffic, an average level or even a peak level. But sized, provisioned your infrastructure on-prem, it can be much harder to resize on the fly, either scaling up to handle peak or scaling back, to operate more economically. Final use case deals with expediting reactions to events that occur in the cloud, specifically in a CRM, right? So maybe when the state of some object, some client opportunity, sales opportunity, or the state of some client relationship changes, there are back office systems that need to be aware of this immediately, right? Relatively low volume compared to the previous two examples, but there's an urgency there, right? We want to make sure that something that changes in the cloud on-prem systems can be notified of that, immediately, right? We deployed this final use case on the cloud in AWS. The interesting thing here is that we, in this example, really maximize the use of cloud services to implement the ETL, right? It's a completely serverless deployment. There are no explicitly defined, configured, or operated servers in this solution. So here's what this looks like, right? The CRM, cloud-based, right, makes some webhook style API call into us when something changes that needs to be transmitted. That call goes through the firewall to an API gateway service. The gateway spins up an Amazon Lambda function that acknowledges the the CRM's call, accepts the payload, and takes the payload and puts it on an SQS event queue, right? So here, it's the SQS queue that's acting as our landing zone. This allows sort of a quick validation and acknowledgement response back through the gateway to the CRM, right? Some of these webhook style interfaces, the CRM system, which is pushing data into us, wants a response, right? So spinning up the Lambda to accept the payload and respond and acknowledge that we got it is key, right? Once it's on the SQS queue, then a additional ETL process is scheduled to check that queue once a minute in this case, and if there are any events there, to process them and send them back through to those back-end financial systems, right? So you can see how little this resembles a traditional on-premise architecture. No explicitly provisioned anything, right? No servers, no database. That Lambda function handles the ingest, the accepting of messages from the outside. The SQS queue serves as our landing zone. There's a cloud compute engine, Amazon's Fargate, handles all the details with provisioning and executing the actual ETL process. And there's a database involved, but there's no explicit creation of a database server either, right? We're serverless. And not necessarily for performance or for scale, but simply for convenience. We don't have to be concerned at all with the state of any specific machine. So in this case, we've essentially fully embraced a cloud-based ETL architecture. So those are three cases, right? We can see probably, hopefully by now, that there's some common traits to these three cases. What each solution is heavily componentized, exploiting cloud storage. In contrast to, as I mentioned earlier, in contrast to the monolithic design patterns that we're sort of more familiar with on-prem. Each architecture introduces the concept of a landing zone for any data that's coming into the system, right? Storage buckets, data lakes, event queues, right? We treat landing the data as a distinct, quick, and complete operation that gets done before invoking actual ETL jobs for business process. And then the final trait in these three cases is that they all exploit the cloud's ability to be elastic in some capacity, right? We can add or remove ETL processors, we can change computing horsepower, we can resize storage, all these things with relative ease, right? So those are the common themes that should have surfaced as we looked at those use cases, right? Of course, there are caveats. The downside are the things to be concerned with, or things that we're not maybe accustomed to thinking about when we think about ETL that we'll need to pay special attention to in the cloud. Costs, right? Cost control is difficult. It can be difficult to estimate, to project and control costs of building and operating our ETL when it's in the cloud. Self-managed cloud ETL is really an a la carte world, right? All of those components we saw in case diagrams, well, they all have price tags, right? Our cloud vendors are going to provide cost estimation tools we can use to project costs of a given architecture, of a given collection of but in our experience, we usually end up paying, more than, or need to plan to pay more for than what these cost estimation tools suggest, right? The cost of operation of the solution is variable as well, right? And that's going to be based on data volumes, or even misconfigured systems, right? You can actually incur some costs simply by misconfiguring the system in production. There are real costs associated with development as well, right? You need to think about oversight of your development team. Very important to prevent inadvertent provisioning of oversized or unused infrastructure, right? It's surprisingly easy for a dev team to provision a large, fast, expensive disk and then forget to destroy it, or to allocate a static IP address to some transient service, or to needlessly auto backup, some test database. All of those things incur cost. Now, in addition to the estimation tools that your cloud vendor will provide, they also provide consumption reports, right? Very important that you, as you start using the cloud for ETL, that you understand where your costs are occurring, either as parts of the infrastructure or parts of the development process or the life cycle, right? You need to use these monitor tools to keep track, right? You can configure them even to warn you if you exceed some spending threshold. I get those alerts, twice a month when I forget to deprovision something. Consider really if you are going to move ETL into the cloud, it's usually a good idea to designate someone in your organization as the service owner, someone who's responsible for monitoring those consumption reports and to understand any changes in those and try to correct them or just be aware of those as we go. Right. Another caveat, there's a new skill set necessary as you move your ETL to the cloud, and that's the skill set around how best to choose the services that you're going to use, right? It's natural because these services that you're selecting from, the security services, the storage services, those would be pretty difficult to build on your own. So while the good news is you don't have to build them on your own, you do need to invest in developing expertise, right, in how these services work so that you can design appropriately. Again, back to that second use case, there are no fewer than 5 services involved in this implementation, right? So choosing those becomes a part of your process that's going to require some expertise that you might not necessarily have at the outset. You need to think carefully about support of your ETL in the cloud. Big cloud vendors have extensive and helpful documentation for all of their individual services. But it's important to note the distinction here that support is going to be very good at telling you how a particular service works. It's not necessarily going to tell you how to make it work for your particular use case, right? You end up with complex questions or queries. Your cloud vendor, Amazon or Azure, they're likely going to refer you to some partner network to get some consulting, which can be costly. And then finally, service guarantees. And by service here, I'm referring to a cloud service, such as a database, and their availability, right? It's not guaranteed. We, for example, found ourselves in a situation where we needed to provision a new Postgres database in a particular region, and our cloud provider could not deliver. It was physically out of capacity, sold out, right? No new Postgres instances were available in that particular region. It was transient situation, resolved, I think, in a day or two, but it is important to recognize that there are actual real physical limits to this thing that we call the cloud, right? So while it's all nebulous and we can provision these things as we want, someplace there is a limit, and those limits can surface in the real world. All right. I'll close, I guess, with a final on selecting a vendor. I showed you use cases with a couple of different vendors. For most of our clients, we see either AWS or Azure as the cloud for ETL. Right? And that decision is usually already made by the time it comes to thinking about ETL. When I opened it, suggested that ETL is sort of a following our data into the cloud, right? So it's very likely that your data and many of your applications are already in a particular cloud by the time it comes time to think about ETL. So sometimes the choice, if you're speaking as the ETL developer, you may not necessarily have a choice. The business may have already made that choice for you. We found operating costs on both of these platforms to be essentially equivalent. So our completely subjective comparison to these two ETL platforms, we think Azure, the console user interface is generally better organized and easier to navigate. We found the sales experience is more friendly on the Microsoft side, particularly for small and medium-sized organizations. Amazon has a larger catalog of services, and those services are generally more feature-rich. And Amazon, by virtue of being larger and older, has the most active user and development community, right? You can almost always find some useful discussion on technical details of building and operating Amazon or AWS solutions. But regardless, really, of the platform you choose, we think it's exciting time about deploying cloud. We wish you luck on your projects. We're happy to meet with you to discuss, your specific goals. And with that, back to you, Tessa.
Great, thanks, Kevin. Hope you all enjoyed that. We have got some questions that have come in, so I'm going to ping them over to you. So someone has asked, does the solution only work in AWS, or is it available in Azure and Google Cloud? I think that might be
yes, I think I showed a couple. We are running in Azure. We see Amazon and Azure primarily. We're also starting to see some uptake in Google. For Clover, in any our products, they're essentially cloud agnostic. We can run in the big three, so quite easy to do.
Great. So someone has asked, what is the value add of CloverDX in these architectures, or is DX simply implementing a solution?
The value add really is to be able to define the journey that the data is taking as it moves, between your systems, right? In almost all cases, as you're moving data around, either between on-prem and the cloud or between various cloud endpoints, as you move your data around, you almost always need to change its shape, or inspect it, or to cleanse it, or to validate it, right? And that's the power that we bring to the table, is the ability to do that sort of transformation of the data in flight, get it ready. The one thing that we know about data as it's moving around in the cloud between our systems is that it's almost always in the wrong format, right? And it needs to be shaped and cleansed and structured so that it can be ready to enter into another system. And that's where CloverDX, I think, really adds the most value, is to be that piece that does that sort of reshaping. And then, of course, we can orchestrate and manage, collections of these activities, right? It's usually not just a single step process. Often many phases or stages that data needs to go through: a transformation step, a validation step, a cleansing step, an anonymization step, right? And we can orchestrate those things.
Okay, so we've got a question here that's similar to the previous one, but the person's asked, could you just elaborate a little further? So when working with cloud providers to implement cloud-based ETL, let's say the choice is between AWS and Azure, from your experience, what would be a more convenient or preferred choice based on the choice of services offered, cost considerations?
Good question, fair question, and a question which probably doesn't have a single generic answer, right? We have an embarrassment of riches, I think, as ETL developers. both of those systems, those infrastructures, well, the Amazon, AWS, and Google all have a very rich set of capabilities, endpoints and services to access, and services those endpoints access. So honestly, it often boils down to other factors, right? Where are your endpoints? Do you have an existing relationship with, one of those? And then, at some point it becomes a Ford versus Chevy question, which one appeals to you, right? You can do, especially when you use a tool like ours, CloverDX, you can make your data, you can create that cloud-based transformation journey in any of those environments with equal effectiveness, right? So really don't have a good answer for you there, other than it's nice to be in a world where we have such a great collection of choices.
Thanks, Kevin. So someone else has asked, based on the message in SQS, Aurora serverless can filter the data, then why connect to AWS Fargate directly?
I
don't know if maybe this question needs a little further, some elaboration.
Right. Yeah, I suspect the devil is in the details, in the sense that the ETL process that Fargate is running for us is doing some fairly interesting transformation of the data, right? Applying business rules to it. But again, happy to dig in deeper, into those details, in a sideband conversation. Yeah.
Thanks. Next one. So what's your advice for running Python-based ETL workloads on Azure?
Well, it's you wouldn't be alone, right? There's lots of people that do that. Can't really think of anything specific. Again, there's nothing magic about Azure versus the others for doing that. As a cloud ETL vendor, we would be interested in what kinds of things your Python code is doing, and why you chose Python. Whether it's you've got an investment in that set of libraries, what you need already. But yes, I'm not sure we can really provide any specific advice there, but would love to talk about the use case.
Great. So another one, just curious, where is the transform done in the architecture?
The transform is in each of our diagrams. You would have seen an ETL box, right? And when it's Clover that's doing that, it's done sort of in memory. As the data moves, from one location to another, right? So different ETL vendors might have different solutions there, but the way we approach it is we have a transformation engine that is being deployed into this cloud infrastructure in some capacity, and it is it's configured to consume data, to take data from some endpoint, do a series of transformations and enrichments, and place the data in at another endpoint, right? And we do that in Clover's in our solutions. We do that with our own transformation engine, and we do it largely in memory.
Thanks. So another question, how about low and no code concept in your solution?
Mm-hmm. I think that final use case was about as low code as it gets, and I do know that there's some that low code and no code has probably some that's new vocabulary, I guess. There's I think there's some contention into what exactly that means based on what vendor or what context you're coming from. So I don't want to overspeak there if you've got a definition in mind for no code or low code. But clearly the cloud, these cloud providers are doing a lot to reduce the amount of code that's required to do these kinds of data journeys.
Thanks. So someone has asked, what is CloverDX exactly? Does it cloud provide any sufficient self-managed solutions?
CloverDX is data integration, right? We live in the cloud. We don't provide explicitly cloud service. We are not a cloud provider, but we provide technology that runs either on-prem or in the cloud. And our specialty is getting your data from wherever it is to wherever you need it, right time and in the right format, right? Because as I've suggested, and I think we all know in these projects, our data is always in the wrong place and in the wrong format for a particular need, right? There's always a transformation, cleansing, enrichment, reshaping process that needs to happen as we move data from point A to point B. And that's where that's our area specialty is that transformation, right? I've showed you examples where, that showed the flexibility of how to deploy that kind of transformation, whether it's in one cloud or the other, or provisioned serverless or containered for scale, and how it consumes data from various endpoints. But our value add as a vendor is the transformation and transformation of that data, and then the orchestration of the journey, watching and monitoring it as it moves from where it is to where you want it to be.
Thanks. So we have someone else who's asked, is the solution agnostic? But then it's a very similar question, so I'll probably kill two birds with one stone. Is there a way to remain cloud agnostic? And a follow-on, how cloud agnostic can you remain? How practical is it to consider shifting between cloud providers and on-prem? And how do you detect infrastructure bloat? Quite a few questions. I'm sorry.
Those are all very prescient questions. And there's a.
Sorry, so happy to repeat if you need me to.
No. I think I've got enough to hook into there. Moving between clouds, the engineering trade-off there is really going to be how fully you exploit particular services, right, and how you design the way you exploit them. I showed one use case where we had a secrets. We use Azure Key Vault for secret storage, right? So you want to make sure if you want to be portable across vendors, then you want to do something like wrap an interface around action to that service, right? So that your ETL process isn't necessarily talking directly to service, some of these service specific service API points. I guess it's hard. I'm struggling a little bit to describe this, but the idea is you want to try, if you design your ETL pipeline in a way that makes you still want to exploit services, storage services and event queues and secret storage, or services, secret key vaults and the like. But if you design your data pipeline to abstract actions to those things, then shifting between clouds can be actually fairly straightforward. The switch between on-prem to cloud is a little more challenging, particularly if you want to take advantage of the cloud, right? You saw, hopefully you saw some strange looking architectures when compared to on-prem, right? Because we're essentially stitching together services. So the move from on-prem back and forth between on-prem and the cloud, if you're really going to exploit the cloud, can be a bit challenging. But you can, especially with tools like ours, design data pipelines that can easily be deployed either in any of the big ecosystems.
Thanks, Kevin. So someone else has asked, how is CloverDX different from AWS Glue? And a similar question, can you give some insight as to how CloverDX differs from versus AWS Glue, any specific features CloverDX provides that Glue doesn't?
Right. Glue's, Amazon's, one of Amazon's services specifically pointed at ETL. Where we provide our value is that we make it much easier to define, we think, the business rules that are involved in when you move your data around from point A to point B. Our CloverDX, we didn't really talk about it in this presentation, but we have other webinars that address this in more detail. But we have a graphical design environment that allows you to, using drag and drop and placing components on a pallet, to design a data transformation pipeline without necessarily writing any code. So it's a very visual way to design ETL, which we think is a differentiator compared to Glue. Glue's a much more, I think, technical, sort of a higher technical hurdle to become a expert in designing ETL with Glue. Designing ETL with our solution is a very visual, very very hands-on way to design a pipeline and to debug the pipeline and to visually see how your data, to actually watch your data flow through various components of the pipeline. So I think we offer a much more business-friendly development environment. And then we service a lot of what AWS Glue does. I think we service in a much more business-specific, business-friendly specific way, monitoring in terms of scheduling, the various stages of your data pipeline. So again, it's a lot easier to talk about these kinds of things when we have a specific use case. But we'd love you to take a look at the design tool, compare our design environment to what you would do with Amazon Glue, and see if that makes sense for you.
Thanks. Kevin, someone has asked, on your slides you mentioned supported platforms. Is Tableau Online one of them, or does your solution only work with Tableau server version?
Don't want to say more, but I'm fairly confident that that Tableau Online can be a source or more. I don't want to overspeak, so I can't say I know that particular endpoint, but very happy to get back to you with a specific answer on that. If there are APIs surfaced by Tableau Online, then we can almost certainly use Clover to build pipelines to either pull from to Tableau Online.
Great. Do you guys support data classification, tagging, canonical form in data lakes, cleansing, MDM, and help in building ODS history data store in data provision layers?
Well, that's a lot of stuff. We don't necessarily have out-of-the-box solutions for all of those things, but we are very comfortable operating in a part of solutions to all of those things, right? We work with operational data stores, we do cleansing, we do catalog. I mean, we're involved in projects where those are the goals, right? To either work with an ODS, classify data. We are not, CloverDX is not an MDM, but we are used inside of some other common vendors' MDM solutions. And we are used side by side, MDMs, feeding them and use them as part of defining a data pipeline.
Thanks. Another question, where is CloverDX located, in-prem or cloud?
CloverDX is a software provider. We sell ETL software that you can deploy on-prem or in the cloud. We're operating system agnostic. We can run Windows or Linux or Mac. We're location agnostic. You can run on-prem or in the cloud. But the key is, I think the differentiator is that we don't necessarily provide a turnkey hosted solution for you, right? You need to decide where to run our software and then run it there.
Great. Is CloverDX similar to SSIS?
We see SSIS, and I would say that some of our advantages compared to Glue surface again when compared to SSIS. You don't have to write much SQL with us, much more visual in terms of designing the rules and watching the data flow, so it's much easier to, I think, design a pipeline, a multi-step data pipeline with our tool than it is with SSIS. SSIS has obviously some advantages in pure Microsoft domains and in domains where you have a heavy investment in SQL that you want to preserve. And we work well in combination with SSIS. But in a greenfield, new project, we would I think we'd give SSIS a really good competition, I guess, in terms of what a solution would look like.
Great. Well, thank you. We've had a great questions. Another minute or so to get any final ones in. And whilst you're doing that, I just wanted to share our next webinar that's coming up. We're going to be running this next week on July 16th, and the topic is running CloverDX in the cloud, specifically AWS and Azure. So during that webinar, we're going to dive deep into the options you have available to run CloverDX in Azure and AWS Cloud. And we'll have a look at the architecture and some best practices when doing so. So the link in the chat there. As I said that, I had another question. So Kevin, sorry, you're not free yet. How would you compare CloverDX to open source solutions that offer ETL capabilities on-prem or in cloud, such as Apache NiFi?
Yep. We love NiFi. It's a really slick technology. Keep coming back to, I mean, the reason people, I think, come to us, again, is, now NiFi's got a visual development environment, but we're much more approachable. It's much easier to, I think, describe the solution to a business problem with a CloverDX data pipeline than it would be with a NiFi pipeline or an SSIS pipeline or a pipeline, right? Simply because we present a framework where you can, manage business rules, where you can manage mapping in a way that seems to be a bit closer to the business domain that you're trying to solve the problem for. As opposed to those other tools that have been sort of surfaced here are great tools and developers love them. I'm a developer. But when it comes time to actually designing a business solution to a business problem that has business rules, I think the design paradigm that you see in our CloverDX designer is much more approachable, explainable, manageable, right? There's no, you're stepping away from code and it's more rule-based and visual mapping based. And it's very attractive when you start thinking about, a business-centered approach to data pipeline development. But again, love to have a chat with anybody who wants to do, who likes Glue and has a particular use case, or who likes NiFi or SSIS. I'd love to have an hour conversation with you about the project you've got and what the requirements are, and then show you what a solution would look like, and maybe we can do some comparisons, right? Always love to do those kinds of comparisons. It's informative for me, I think, as well as you.
Right, thank you. I don't think we have any more questions, so we'll wrap up for today. But again, thanks everyone for attending, and thanks Kevin for a great web. We hope the next one. Like I said, the link to that one is in the chat. Thank you.
Thanks everyone.